Hey everyone, thank you very much for coming along. This is how to build a Raspberry Pi robot arm with .NET 5, Blazor and Signal R. We are at Developer DDD 2020, which is a fantastic achievement, and congratulations to everybody involved in making this event happen. I don't think anybody thought we'd get a DDD this year at least, so to get a virtual DDD happening is some achievement. Before we get going, we do have a code of conduct. There are a lot of words on that screen, but it boils down to be nice to each other. This is an inclusive event, so obviously feel free to ask questions, but just be nice and we'll all get along. There's a really important organisation that DDD are involved with, and that's the National Museum of Computing. And they've got everything from Colossus to calculators, from slide rules to software down there. So they are in constant need of money to keep this awesome place alive and kicking. So you've not had to spend money traveling and paying for hotels, so perhaps kick a little their way and keep them going. It's amazing. And then obviously after today's event, then go and, as soon as you're able to, go and book yourself a slot and go down and see what they're doing. I think they're going to be doing some virtual tours at some point as well, so get involved with that. I would also like to thank the amazing sponsors. There's a whole heap. I won't call them all out, but this event couldn't happen without their dedication and ongoing support. So thank you to them. If you want to get involved on social media, then there's a hashtag DDD 2020 and at Developer Day as well. And you can tweet at Pete_codes if you want to tweet me too. So a little about me first. There's a lot of words on my screen as well. I like to be involved in pretty much everything. I concentrate mainly in the IoT space. I've been doing that for decades now, so it's what I know and love. I'm also quite active in the community as well. I'm involved with organising 3 or 4 different meetups, and I'm also in a podcast and a live Twitch stream. So there's plenty going on there. I'm also a STEM ambassador, and that's driven by the fact that I've got 2 naughty young girls at home. So I'm quite well motivated to make sure that they have all of the access to STEM subjects and tech that they should have. So what are we going to do today? We'll start out just by looking briefly at .NET and .NET 5 specifically, and then how easy it is to install .NET 5 now on a Pi. And then we'll do a couple of hello worlds just so we can set the baseline. And then we'll start talking about GPIO, general purpose input output on the Raspberry Pi, and look at the circuits we've got building. And then we'll look at device bindings and how we can drive servos, little motors as well. And then we'll move on to Blazor and Signal R and a final demo. And then the Q&A if we have time, if I don't overrun afterwards as well. So if we move on now, so .NET 5, you can do pretty much anything you like with .NET 5 now. It goes across everything from desktop through mobile and AI and IoT as well, luckily for us. So what's new in .NET? Well, since we had .NET Core, then .NET became open source and cross-platform, which is fantastic for us because it means we can run .NET on the Pi. We've got some new C# features as well, including records. Init-only properties where we had something like this before, and then we can just now set properties only on init, which is fantastic. We've got pattern matching, so we can do switches on types here, which is fantastic. We can also do top-level programs. So before, the boilerplate for Hello World used to look like that, and now it's just 2 lines, which that for demoing and for students getting involved is fantastic. And we've also got system.text.json, and of course James Newton King's a little bit upset about that because that gets rid of his JSON. So just a little bit about .NET and the ecosystem. I've not got the details for .NET 5, but certainly .NET Core, there were over 1.5 million .NET Core developers in Visual Studio. And it's .NET Core was the #1 most loved framework on Stack Overflow as well. And in the top 30 highest velocity open source projects. It's the top 5 C#'s top 5 language on GitHub, and ASP.NET Core was 7 times faster than Node.js, which is incredible. The stat I like the most is that 40% of new .NET users are students. So that really shows now that .NET is making its way into education, which is really cool. You can find out a little bit more about it with that link down there at the bottom from Build. with the two Scots. That was a fantastic session. Installing .NET on the Raspberry Pi used to be quite a few steps involved in that. And if you weren't 100% au fait with Linux, then some of them were a little bit, confusing. So I've made a script, a single line install script that you can get .NET 5 installed on your Pi just by running that single line there. I try and keep that as up to date as possible, so it should install the latest version of .NET for you if you run that particular script. You can go to my GitHub repo and you can see how that actually works under the hood. So don't blindly install anything someone tells you to install without at least first checking what it's doing. So the first thing we need to do is just make sure that we've got .NET 5 installed correctly and that it's running. So over here, I've got a putty session open, an SSH session into my Pi. And if I do .NET-info, then we can see here that we've got .NET version 5.0.100 installed. So that just proves that we've got .NET installed. And once you run that single line install script, this is where you'll be at. I've spun up a simple console app as well, which we can see in the background just over here. And there's not much to it. It's literally just going to be hello world. And this is a really good place to start once you've made sure that you've got .NET installed. If you go ahead then and just make sure that that works. And so I'm in that directory now. And if I do a .NET run, and I'm running this on a Raspberry Pi 4, so it's not going to be as powerful as your multi-core PC, but it's pretty fast, to be fair. So that'll finish running, and there we get hello world. So that's really just give us a baseline of how things are actually working on the Pi, and we're happy now we can continue coding. So before I move on to the next demo, it's worth talking about .NET Core and GPIO. There's a nice NuGet package, the system.Device.GPIO package, and that supports all sorts of I/O, including serial and PWM. And it also works on a Raspberry Pi and BeagleBoard and Hummingbird. And the great thing is it's cross-platform, so it'll run on Linux as well as Windows 10 IoT, but I don't tend to concentrate anything on that anymore because I think it's kind of losing support. You can install it from the CLI, this package, or from the NuGet PM if you're going to use Visual Studio. Raspberry Pi GPIO, if you don't know what that is, that's general purpose input-output. So we have things like basic inputs to be able to drive LEDs or read buttons and things like that. But we also have serial ports and PWM ports and things like that as well to drive special devices. There are actually two different numbering systems in place here. These numbers here closest to the Pi pins is the board numbering scheme. And then there's also a BCM numbering scheme. Now, this is important when we start setting up the GPIO controller because we need to tell it which board numbering scheme we're going to be using. I prefer to use the board numbering scheme because it's one number and I can just count the pins, whereas the BCM numbering scheme, I've got to convert that to a pin number afterwards in my head and miscount and all sorts. BCM refers to the BCM chip on the Pi. So we'll be using the board numbering scheme. This is the basic circuit we've got. So if I zoom in a little bit on pin 10, I've got one side of an LED that's connected then onto an LED, one side of a resistor that's connected onto an LED. We need the resistor in the way because we'll draw too much current out of the Pi pin if we disconnect it directly. The other side's then connected down to ground. Then I've got pin 26 connected to one side of a button, and then the other side of that is connected down to ground. So this will give us the basis to be able to test that we've got control over the GPIO. So this is hello world for IoT applications. Now, I'm not going to do any live coding here because I'm not quite that crazy. I'll save that for Twitch. But what I have got, I've set up a bunch of branches. Now, all of this code is on GitHub, and there's a workshop in there, and you can run through all these branches yourself, or you can do follow the steps in the workshop and get to that point too. It's entirely up to you. But we're at the start here, and I'm going to switch over to reading the LEDs if I can find them. There we are. Flash the LEDs. And so we've got some new code in here. If I flick to the CS project first, you'll see here on line 17 that I've now got a reference to the system.Device.GPIO NuGet package that I mentioned earlier. In the program here at the top, I've referenced that system.Device.GPIO, and I've also pulled in the system.Threading library too. I've left the hello world in there, and I specifically leave that in for my IoT solutions because when you start it up, sometimes it can take a while and you're not sure whether or not it's ready, and maybe you're pressing buttons and waiting and it's not doing anything, and really it's just it's running itself up. So over here on line 14, we're creating a GPIO controller, and this is what's going to be doing the heavy lifting of most of our applications here, most of our demos. And you can see here we're passing in this pin numbering scheme of board. So that's what I was referring to earlier. I'm creating a couple of variables here, and we're referring to pin 10 here. If you remember from my circuit diagram that I had earlier. Oh, going the wrong way. Spoilers. You can see we had the LED connected to pin 10 and the buttons connected to pin 26, which we'll see shortly. Down here, I'm opening a pin, and I'm opening it as output. So I'm going to pass in that pin number of 10, and I'm going to set that pin to be an output. And then I've just got a really simple loop going here. So I'm just going to go around this loop, and I'm going to write a high value to the pin, which will turn the LED on. Excuse me. And then I'm going to sleep for that 300 milliseconds that we created at the top there. And then I'm going to turn the LED off, and then I'm going to sleep again, and then just keep doing that. And then at the end, we can close the pin. It's always a good idea to close pins after you finish using them so that you can free the resources. So let's just make sure that works. I'm going to flick across to here again, and we'll just do another .NET run. And what I've got is a camera, and all being well, yeah, that's live. So that's pointing down here at my circuit, and you can see here that we've got that little circuit, and there's our LED flashing. You can also see the robot that we'll be controlling shortly. And you can also see that we've got a little button just there. And that's the next part of what we want to do. So if I go back to our code and we switch, in fact, what we need to make sure we do is something that I am constantly forgetting to do, is stop the code. Otherwise, when I switch branches, that's going to cause us problems. So the next thing we want to do is read the button. So that's going to leave all these usings pretty much the same, and everything to here is the same as well. So we're still creating the GPIO controller, but we've now created a button pin variable. And again, if you remember, we're on button pin is on 26, pin 26. So that's the 26 that we've got here. And we're going to still open the LED as an output, but now we're going to open the button pin as an input, and we're going to pull up that input. That input will get pulled up inside of the Raspberry Pi. The reason why we need to do that is, if you remember from the circuit there, we've got one side connected to ground and the other side is just connected to a pin, and it's looking at that pin. So if you just leave that pin and don't do anything with it, it'll be floating around and you're not going to be quite sure what level that's going to be at. So we pull that pin up to a high value so that we can make sure that it starts high. And when I press the button, then it's going to take that pin low, and we can read that in then. So if we look a bit further down, we can see we've got that same loop we had before, but inside the loop now, we're going to read our button pin in here. And if it's false, so if it's low, then that pin will set the LED to high then at that point. So it's going to seem a little bit backwards. So if it's false, then we set the LED on, but that's because pressing the button will take that pin low. So let's just see how that works, shall we? I'll switch back across to here. And we should see when it's ready, that LED should turn off, all being well. There we go. And now I should be able to press the button and the LED comes on. I mean, that's the most complicated circuit you're ever going to make, essentially. We've got a Raspberry Pi in the middle. I could have just connected the button straight to the LED, but this now proves that we've got control over the GPIO. We can read inputs and set outputs. So that's a pretty cool position to be in. So the next thing we want to do, if I switch back to my slides, is talk about the IoT device bindings NuGet package. This is a fantastic set of somebody else's code that has got support in there for things like temperature and humidity sensors and I/O expanders and Explorer hats and Sense hats. If you've never seen a Sense hat, then I've got one here. I don't know how easy. Oh, there we are. So you should be able to see that. Now, this is one part of something that's gone up to the space station. Tim Peake, when he went up there, took 2 Raspberry Pis, and they've got these Sense hats on top of them. and students can make experiments that run on the space station, and they get the results back. It's absolutely fantastic. And that's all written in Python normally, but you can control that sense hat for your own projects using C# now with these device bindings. And luckily for us, there's also a Servo package in there as well. So this is the basic circuit that we've got going on. It's not all that basic actually, but there's not that much to it. You've seen the LEDs and button part of the circuit, but I've bought this Monk Make Servo 6 board. It's about 15 quid, I think. And what it allows you to do is control the amount of power that you're going to give to the servos. The servos, if you try and connect them directly to the Pi, they're not going to be able to take enough power from the Pi and work properly. So I'm kind of hoping the batteries are going to last actually. So I've done a few demos now. I've got some spares. But you connect that up to the Pi just by the individual control wires, and the rest of the power you get from that top left hand part where you can see plus V and ground, and you just have a battery pack connected to that, and that means that the Pi just concentrates on driving the servos, and the Monk Makes board just controls the power, which is great. You can see here that we've got the ground pin connected to pin 25 here on the Pi. That's a ground pin. And then pin 35 there, that goes to the pin labeled 1. I find the numbering scheme a little bit confusing on that board, but you can see directly in line with that blue wire on that pin, that's the first servo control line. And then pin 13, that's connected to pin 2. Now these are the two hardware PWM pins on the Pi. We've only got 2 of them. There is some software in that library for software PWM, which I connected a pin to, but it doesn't work very well, and you'll see a bit about that at the end. So we're only going to be controlling 2 of these servos today. On the other side of that Monk Makes board, there's a connector for all of your servos. Now that's a pretty simple control there. You've got a control line, which is either yellow or orange, depending on which set of servos you buy, and then you'll get a red and a brown, and the red is positive and the ground, the brown is ground. So just make sure that you connect the orange or yellow to that C pin. You can't quite see it on there, but it's labeled C on the board. Once you've done that, then you're rocking and rolling. So let's make these servos on this little robot arm move, shall we? So if I flick back to my code and then we switch to the move servos branch. I like branches for demos because it just takes, well, hopefully all of the problems out. You don't have to watch me typing, and you also don't have to tell me I've missed a semicolon. So it's all good. What we've done here is we've added here on line 17, we've now got the IoT device bindings NuGet package we've pulled in. And then back in our program, we're referencing the system.Device.Pwm. So the system.Device was the same thing that we're using for GPIO, but there's a PWM library for that. So that's where that comes from. And then the actual servo control, servos are driven by PWM. So that's pulse width modulation. So the bigger that pulse is and the bigger the width is, the more your servo will turn, and the positioning of that is controlled that way. I won't go into great detail for that, but that's essentially what it's doing. So that's why we need PWM and then the servo library to be able to control that. We can see we've still got our hello world, so I know something's happening. But we've also got this PWM channel we're spinning up. And we pass in 3 parameters. The first one is the chip number. There's only 1 chip number on the Pi, so we pass in 0 there. Then there's the PWM channel. And again, there's only 2 channels. So there's 0 and 1 for PWM channel 1 and 2. And then we've got the frequency here as well. I don't play with that. 50 works. Let's just leave that alone. Then we create a servo motor and we pass in that PWM channel. And we also set in there the max positioning, so it can go between 0 and 180 degrees. And then there's a min and a max frequency, pulse width rather, that we pass in here. And depending on the servo you buy, you might need to tweak these, and it really is just trial and error. I got this to work pretty much with those figures there, 700 and 2,400. And these are just like 25p servos from Amazon, pretty cheap things. And we've got that again for PWM channel 2. And then we start our servo motor up here with that start. And then I've created at the bottom here a tiny little sub that takes in a servo and an angle, and then it writes the servo.right angle with an angle, and that will position the servo to that particular angle. And you can see here then that I've got move to angle my servo motor 1, and I'm setting that to 70 degrees. And then I'm going to wait for 2 seconds. And then servo motor 2, I'm going to set to 20. And I'll show you this working in a second. And then 150 for servo motor 1 and 50 for servo motor 2. And then I just go around that loop and stop the servos if I need to at the bottom. So let's see that working, shall we? Stop that. Hopefully, I left it running. Hopefully I've not caused it any problems when I do that now. Should be fine. So if I switch across to here, good. So it's doing something. So if you watch it, it's going through that routine now. A little servo dance. But that's a big step that we've just taken there now, because we've got the controls for a robot arm now. And I know it's not particularly complicated, but it is still pretty cool. And I was chuffed when I got to that point. Servo motor 1 is this one down here that is driving the kind of the up and the down of the arm. And then servo motor 2 is this one here with the little pincer on it. You do have to be a little bit careful with the angles that you put, because you can hit the end stops, and if you hit the end stops too much, so 0 and 180, then you can strip the gears in the servo, and it's not ideal. So that's the basics of the robot arm just there working, which is great. They've kind of proven that that's good, but we can't control it, can we? We're not controlling that robot arm. So I'm going to stop my code, because otherwise that's going to be squeaking at me the whole time. Interestingly, while you're doing this, I don't know if you can hear this. It might not be picking that up, but you get a vibration every now and again. And that's because of how this PWM works. It's kind of floating in a position with PWM. And if you've got something hanging on the PWM, the servos, then it can sit there and it'll vibrate. So if you ever hear that, that's what that is. By the way, you can just go ahead and ask me questions in the Q&A. I'm just going to check that now that I've got to that point. So does the GPIO library still require to be running as root, or can this code run as privileged? Well, the .NET stuff handles that for you, thankfully. So I've not needed to do any sudo .NET run or anything like that. In fact, I wouldn't even know what it'd do if I did try and do that. So no, it just runs, which is great. To be fair, I think I've run the .NET stuff on versions of Raspbian that have required root, because I think in the later versions of Raspbian, they introduced a new GPIO control that meant you didn't need to run stuff as root anymore. But no need to do that. It just sorts it out. It is a good point. If you're going to do stuff with Docker, then you do need to make sure you run the Docker image as privileged, because that does need to have access to it, and quite rightly so as well. I picked up a Meadow board this week from Rob, an MCU. You can run it on .NET and write. So yeah, the Meadow's fantastic. And Cliff, I think in the previous session, his session was fantastic. And Rob, if that's you, Rob Miles, then your session was cracking as well. I'm going to make sure I sit my daughters down at the YouTube recording, if there is one, and watch that. So yeah, the Meadow is brilliant, and do go ahead and check that out. That's an Arduino you can program in .NET, which is great. And that's full fat .NET that you can do on that. Doesn't that dispose of the channel before you use it? No, in that code there, down here, this finally down here doesn't get to anywhere, because I was sitting in that while loop forever. So that never actually happens. I hope that explains that. Looks odd to me. Hopefully that explains it, Richard. But do get back to me in the chat if you've spotted something. To be fair, I don't think I ever get to these lines, because if I Control C, it just stops the loop and stops the program. So I kind of leave it in there, because if you're going to do something way more complicated than what I'm showing, then you're going to need that control level there. So it's good to see that. So moving on, I see I'm 20 minutes in. That's not bad timing. That's good. 24 minutes maybe. So the next thing we're going to talk about is Blazor. So Blazor is a single-page app framework that allows you to code in .NET for your front end, which is fantastic. It's started out life as a pet project of this guy, Steve Sanderson. He demoed it at a Microsoft conference, and some people from Microsoft spotted it and just jumped on it, because, or not the finally, no, the actual using higher up. Oh, maybe, I don't know. It seems to work. Yeah, you would have thought you'd have to put it inside the using. I mean, I copied their demo code, to be fair, Richard. So yeah, maybe somebody else could tell me why that's still working. It still seems to work. Good point. So yeah, sorry, Blazor. So this allows you to be able to write your web UI in C#, which is great because you can just get rid of JavaScript at that point because, you know, no one likes JavaScript. You still get your Razor in HTML, so it's a bit ASP.NET-y in that respect, but we've got server-side and client-side WebAssembly. So server-side, as its name suggests, lives on the server, and you have a thin client running on your browser, and the server-side just passes DOM changes down to the browser, and it just makes those updates, which is great if you want to make sure that sort of you're keeping your code secure and you don't want that code to go anywhere. Maybe that disposed of stuff. Yeah, that's entirely possible. Somebody else's code. Yeah, so if you want to keep your code secure, you can keep it on the server and just send the DOM changes down. But of course, the future is WebAssembly, and that's what we're going to be looking at here today. But I mean, the bonus here is that we can do .NET on the client without any plugins like Silverlight. Paul Laurent Bignon, I know he liked Silverlight. And it's supporting, I don't think the most word works anymore because it's in all modern browsers. You can find out a little bit more about it if you hit that bit.ly up. We're going to be combining Blazor with SignalR. Anybody that's seen any of my talks before, normally I'd be doing everything with Azure IoT. But I wanted to show the real-time nature of what we could do here. And SignalR is specifically that. So it allows you to add real-time web functionality to your applications. It's really good, works really well. It's an open source project again, created by these two guys here, David Fowler and Damien Edwards in 2011. So it's old now. I mean, it's nearly 10 years old. And it enables bi-directional communication between applications, which is really good. It supports WebSockets at the top level, and most of the time that's what you'll be using. But if you don't or can't support WebSockets, it can drop down to server-side events and long polling. So it's fantastic. So we need to drive the ARM. So there's a few things we need to do. We need to make sure that we can set up SignalR both in our Blazor app that I'll show you in a second, and also then on the client. But the first thing I want to do is just show you the Bob, I think that's the new C#8 feature that allows you to apply the using to the call scope rather than the map braces. And a link. That's fantastic. Thanks, Bob. So flicking back to my code now, the SignalR app I'm going to run on my PC, Blazor SignalR app on my PC, and then the Pi is going to be running its control code. So I've got two lots of VS Code open that look almost identical, and so I'm just going to have to remember which one's which. But I've got the code here set up with just a vanilla Blazor app that we'll all have seen if we've used Blazor, and if you haven't used Blazor, then I'll show you what that looks like. And I've got that set to debug in here, so I can launch and debug this standalone Blazor WebAssembly app by just hitting the F5 key, and assuming it all works correctly, then we should get a loading. There we are. And then we'll get the vanilla Blazor app. I mean, it's good to do this anyway, just to make sure that everything's working before you start putting your code in. If you've not seen it before, then I think this is a really nice out-of-the-box experience from a new Blazor WASM app. So you've got a little counter that you can increment there, and this is an API. I've actually spun up a Blazor WASM hosted app. So if I stop the browser there and also shut that down, then if I look at the files, then in the web client here, we've got a client and a server and a shared directory. So the client stuff is the WASM app that's going to be sent down and run on the client browser in a virtual machine as bytecode with all of the .NET DLLs just as they are. And then the server stuff, as the name suggests, that's going to run on the server. And I need that because I need to create the hub in a place that can be accessed. So that's what that's going to be there for. And then shared is stuff that we can share across, like models and stuff. You'll see that there's the weather forecast stuff for that API in there. We're not going to do anything with shared at all, as it happens. So I'm not going to go through and explain how all the code works because we've got better things to be getting on with, and we're already halfway through, or in fact more. It's half past. I've got 10 minutes. It's good. We're fine. So I'm going to switch this across to adding some Blazor controls. And what I've done in this particular branch is I've added something called Mat Blazor, which is a set of UI controls because I want a couple of sliders. And there's a few things that you need to do to get that working. You need to import the Mat Blazor bits in there. and then we need to, in the WW root, we need to add in a couple of JS and CS bits and bobs to get that to happen. And there's a couple of other things, but down on the index page that we've got, we have got some stuff for Signal R that I've sort of scaffolded in there already. And I've got then these couple of servo sliders, and I'll go through how that code works shortly. But over in my Pi side, so if I switch across to the Pi code, I'm going to switch that to adding the Signal R stuff to that. So, and I'll just quickly talk about what I'm doing in here. So in my CS proj now, I've got this Signal R client, and this is going to allow us to connect to the Signal R service that's going to run in our Blazor app. So again, PC is going to be running the Blazor and Signal R stuff, and the Pi is going to connect to it, and we're going to send messages between the two. So in the program down here, and forgive me, I'm going a little bit fast, but you know, we've only got limited time. I've still got the two PWM stuffs there that Bob has very kindly pointed out must be using a C#8 feature to encapsulate this and keep that going, which is cool. Still start them up, but now I'm creating this Signal R connection, a hub, using the hub connection builder, and you pass in the URL you want to connect to. I happen to know that my URL is 192.168.1.162, I think, and I'm just going to double check that for my own sanity. Yeah, 162, that's good, and that's the IP address of the PC that this needs to connect to, and it'll call out to this chat hub URL here. And I also pass in this extra configuration. Now I've needed to do that because for some reason it won't trust the certificate that's on the PC. I saw a few tweets about the fact that you need to clear certificates, but that didn't seem to work for me. So I didn't. So that should build up the Signal R connection. And then from the connection, we wait for this receive message that comes along. And that message will contain a user and a message. If you're ever going to do Signal R and you do the first app, then you'll find that it'll be a chat app. So that's what that'll be all about. So a user and a message. And with the user, I'll set as being the Servo 1 and Servo 2. And then we're just going to use that same move to angle routine that I had before. And we're going to convert the message, which will just be the angle, into the angle we want to pass. And then we start the hub connection down here. And then we can just leave it as it is. It'll just sit there and be happy. So that's all good. So switch across to our Blazor code, and I'm going to add in the Signal R code. That's this one. And so down at the bottom now, we've got our control code for those two sliders. I'm not going to spend much time explaining how these are working, but when I move the slider, they're hooked up to these two properties here, Servo 1 and Servo 2. And when that property changes, I call across to this send message, and I pass in Servo 1 in that case, and servo.toString, which is our value that we've got for this, is the angle. So that slider is the angle that we're going to be controlling. And then a little bit further down, we build the actual hub connection in here, like exactly the same as in the Raspberry Pi code, and we connect to it. And the actual hub itself is created in the server, and it's in here in hubs. And there's some other stuff you need to do, but we've only got 5 minutes left. But you can create the hub, and you need to inject that hub then into your Blazor code, which there's a bunch of stuff you need to do, but some of it is in in startup.cs, where we map that that chat hub, and then the rest of it you will be doing sort of with this part here when you do that, and you inject this navigation manager and bits and bobs. So that's how that connection is working. There's a little bit more about that in the workshop. So I'm going to start this code up. And what I find is that I often have to refresh this. We've got 6 minutes. That's plenty of time, more than enough time. It should just start. It takes a bit longer because we're not a vanilla program anymore. And this is the part where I've got to refresh it. And there we are. Now we've got something that looks a little bit more sensible. So these two sliders for Servo 1 and Servo 2 that I explained earlier. And then if I switch across, just make sure that we've got the code that we want there. So that's the whole Raspberry Pi code sitting there. So if I get that running, and then we should see it'll do something in a second. Oh, there we are. So it did something at that point. So now I need to find my browser. Oh yeah, well that would help. Let me just get that over here because it's hiding now, of course. Oh, it's this one here. I am going to grab that address. Oh, you see, I didn't plan ahead far enough, did I? Look. This is the robot arm I've built, by the way. You can just, I've got the address for that, the URL for that. So I'm just going to dial into this. And then, all being well, I'm going to move this out of your way so that you can see what's going on. I'll move this. And now you can see that's servo 1 that I'm moving. And then, look at that. It's a little bit rickety because I've not screwed it down. But you can see now that I can move, if I drag this down and put it down so you can actually see what it's doing. And if I move this, you see the robot arm moving. That's probably a better place, isn't it? That's pretty cool. So that's Signal R sending messages down to the, and in fact, if I go back here and have a look at this, you can see all the messages. So they've been received by the Raspberry Pi in real time and in steps of 1 degree. So I mean, essentially that is the demo. So I was quite chuffed when I managed to get that working. So real-time control from a web page, and obviously you could use that as a robot arm here from Rob as well that he's suggested. Let's have a look at that, in fact. Oh yeah, that's a good one. I like that, Rob. Yeah, you could absolutely use that. It looks like, are they like the same like 10G servos in there? I mean, obviously you're paying 60 quid, but you've also not had to pay hundreds of pounds for a 3D printer and also wait for a long time for it to print. That's a really good call out. So yeah, that thank you, Rob, for that. That's definitely a good one to do. So that's pretty much the end of that demo. So we can switch back to my slides now. And it didn't all go according to plan because I had some little help from my furry helper. She seemed to love these servos. Also, I tried controlling that third servo using software PWM. That doesn't work particularly well. And also, you must make sure you screw it down because although it seems to work well for a little bit, if you don't, then the whole thing is just going to fall over. So a little bit of a funny for the end, but here's some links. So as I say, on my GitHub here's all of the code that you've seen today, including a whole workshop for you to be able to go from start to finish all the way through, and hopefully that will give you everything you need to get to the point where I am today. If you want to find out a little bit more about C# and .NET 5, then there's a link there for that, as well as a link to my blog there about how to get .NET 5 installed on the Pi and control an LED and a resistor. There's also a link there for the GPIO NuGet package, as well as the Device.Bindings source code. If you go to that Device.Bindings source code, you can just scroll through an amazing amount of different devices they've got there for you. It's amazing. And then there's the link to that 3D printed robot arm. Rob, feel free to tweet out a link and tag me, and I'll retweet that for that other robot arm. That's fantastic. If you want to find out a little bit more about Blazor, sorry, that's a little bit small, then there's a link there for that. And then that Map Blazor set of libraries there, as well as Awesome Blazor, which is a collection of fantastic Blazor resources. And then some more information on Signal R. If you want to find out a little bit more about IoT, then I run Knots IoT. And this Thursday coming, we've got Catherine Makin and Mohit Boita coming along. Catherine Makin's a fantastic artist who does sort of astro art, and she does technical astro art as well. And Mohit Boita is works for Particle and makes some amazing contraptions out of brass rods, and you really need to see the stuff that he makes. It's cracking. If you wanted to start thinking about Azure IoT, then I've started making a series of Pluralsight courses that will take you towards passing their certification, the AZ220 certification. So do go and check that out on Pluralsight if you get some time. And in fact, if you want to, then I've also got some free licenses. So feel free to send me a tweet, and I'll be able to get you a 30-day free trial for Pluralsight. If you want to get in touch with me, then there's a plethora of different ways, but at Pete_codes on Twitter is by far the best way to do it. I tend to miss emails, but contact me at any of those places and come along to any of the different community events I'm involved with, from Knots IoT, .NET Knots, Knots Dev Workshop, Lati, the Agile Engineering Podcast, and Azurish Live. And later on today, I'll put the slides up at that link, the DDD 2020 link as well. So thank you very much. And has anybody, Anonymous, put weights on the bottom. I like that. That's probably a good idea, or I could just screw it down, but you know, I was footering with it, so I didn't want to do that. But yeah, good point. I like that. Is there any more questions? Has anybody got anything else they'd like to say? Obviously, pipe up in the chat, or you know, if not, then feel free to tweet me out. I'll make sure I put a link to the slides out there too for you to look at. So thank you very much for coming along, and I hope you enjoyed seeing my wobbly robot arm moving around. Thank you very much. I'm just waiting for some questions in case there are any. You can ask me anything, you know, it doesn't necessarily have to be about that. Do obviously go and check out the Museum of Computing as well, because that is an amazing place. And you can double up and go to Bletchley as well afterwards. It's well worth going. So it looks like pretty much it. So yeah, thank you again, and I'll see you soon. Cheers, Cliff.